Folks, there are some very powerful math, science, geography, environmental studies integration you can do with ArcGIS Online, specifically the 3D scene viewer, the line of sight. I'm going to explore those tools with you for a moment. I'm going to look at North Table Mountain in Golden, Colorado, USA, but you can look at any landform you want across the world and do the same thing that I'm doing here. Again, integrating different subject matters and doing some measurement with real-world places. And if you can get out into the field with your students, all the better to look at these things on the ground. I'm looking at line of sight. The green indicates that you can see from the observer to the destination. The red means that you cannot see that portion of the terrain. So you can rotate, zoom, and pan as I'm doing here. You could change the base map to imagery if you don't like this shaded relief. But you can see here that if I'm on the ground looking up at that mesa, wow, I can see that, oh goodness, I can't see the top middle of the mesa. I can only see the edge. And conversely, if I'm standing in the middle of the mesa, I can see the edge of the mesa, and I can see in the far distance, but I can't see directly below me on the mesa, which makes sense. So you're fostering spatial thinking here is what you're doing with these tools. Line of sight, 3D scene viewer, ArcGIS Online from Esri. Fascinating to be able to do this. Okay, let's look at the dimensions tool. This is another powerful thing. Look at the dimensions tool. It gives you the distance, miles, kilometers, meters, whatever unit you want to use. Notice how the end point is deeper because of the terrain. It's using some pretty powerful analytics behind the scenes, a digital elevation model of the Earth at high resolution, so it knows what the surface elevation is at any point on the Earth's surface. So I can plop a point at the top of this mesa, and I can put it down in the valley. Oh, I just love to be able to do. I love being able to do this. Again, powerful math, science, environmental studies, geography, terrain visualizations here, before or after you get out in the field with your students. And then if you also check out this, if you look at different change the different units, you can foster how do I change between imperial and metric units and so on. Being able to slice, you can make a slice of the scene so you can visualize the landscape that way. Indeed. All right, let's take a look from south to north now, and let's take a look at creating an elevation profile now. So elevation profile, rise to run, classic topographic interpolation here. Across the top of this mesa, it's pretty flat. That's why it's a mesa. And now I'm going to drop it on the valley floor there, the Clear Creek Valley in this case. I'm going to drag this endpoint all the way across the valley now to the top of the next mesa, which in this case is South Table Mountain, and look at the terrain there. Notice how it looks pretty deep and narrow. It's not actually what it looks like on the actual Earth's surface. So if I rotate the view, I can see what it really looks like. It's a fairly broad valley there. It's about a mile across. So because of the graph, the X and the Y coordinates, it has to be compressed into that small box, as you can see. But on the ground, it looks a little bit different. So I think that's another powerful thing to teach students. Now I'm going to drag the northwestern point up to the base of the Rocky Mountains here. You can see the elevation is going to vastly increase as I go up to the foothills of the Rockies. Now I see, again, the graph is slightly different from the map. The map or terrain view is a bit wider. The graph has to compress it into this smaller space. But look how the green line is draped across the valley floor where Golden, Colorado is. So why do people locate in flatter areas rather than steeper areas? All kinds of things you can teach here with the 3D scene viewer, Esri, with the tools that I'm displaying here. Get out there and explore.